data. Okay, so now let's take a look at variance and standard deviation. So what are they basically? So they represent how consistent the data is. So the lower the variance or the standard deviation, the more consistent the data is. So consistent data means that it is near each other. So 2, 3, 2, 4, 1, 2. So all of the data is very consistent. It is very near the mean value. So most of the data is near the mean value. Okay. So how do we calculate variance and standard deviation? So in ungrouped data, the variance formula, basically the variance formula, regardless of ungrouped or grouped, is the mean of square minus the square of mean. This is what MSMSM represents, the mean of square minus the square of mean. So what we're doing is we take out the mean of x square and then we subtract the mean of x whole square. Okay, so there's another way of doing this, which is that we sum x minus x bar whole square. So we sum all of this and we get the variance, and divided by n, which is the number of items in the data. So standard deviation is basically just the square root of variance. So first of all, you'll have to take out variance and then you'll just square root it to find the standard deviation. So this was how to take out variance for ungrouped data. Now let's look at how to take it out of a group data. Okay, so in this group data, the formula is basically the same. But because in group data, the formula of mean is sum of fx upon sum of f. So to take out the mean of x square, we'll have to do sum of fx square upon sum of fx. And then again, this mean of x is sum of fx upon sum of f, and then we'll have to square this. So this is what we're doing here. You can also use this formula. Okay, so to find out the variance, first of all, we'll have to take out the mean of x square. So for that, we'll have to take out x square. We took out x square. We have to find fx square. We multiplied fx with x to get fx square. So we take out the summation of fx square, which is 429. We do 429 upon the sum of f. In this case, it's 13. Then in the formula it says the sum of fx, which is 73 in this case. So you'll have to calculate all of this fx square and x square, and then upon fx, which is 13, and then you'll have to square it. So this is basically the variance of this set of data, and to find the standard deviation, you'll basically have to square root it, and the answer will give you 1.21, which is the standard deviation. Okay, now let's look at how we can take out variance of a combined set of data. Okay, so let's suppose we're given a combined set of data and we have to find the variance of that. So basically what we do, like we took out the mean of a combined set of data. In this, we will again consider it as 1. We will add the values of the square of each data. So the summation of x square plus the summation of y square will give you the summation of this, let's say z square, and we'll find the summation of x plus summation of y, which will give you this, which is again, let's call the summation of z. So we'll take out the variance of z, and this will give us this, which is the combined variance of both of these set of data. And then to take out the variance, we will simply square root it. Okay, so like we did coded data in mean, you can also code the variance. So if we subtract anything from the variance remains the same. Nothing happens to the variance. But if you multiply something with the variance, you have to multiply the square of it to get the variance of x. So to get the variance of x, if you multiply something with a, you'll have to divide it by a square. Okay, now to find the ungrouped coded data, you'll have to use this formula, which is basically the sum of x upon n, sum of x square upon n minus sum of x upon n whole square. And in this, we'll use the sum of fx square upon sum of f minus sum of fx upon sum of f whole square. So similarly, we'll use, if something is being subtracted by b, it won't have an impact on the sum of in the variance, so we won't have to do anything with that. But if it's being multiplied, we'll have to divide it by the square of that. So similarly, we're doing that in both these cases. This is the normal variance formula for both grouped and ungrouped, and we're just multiplying it by 1 upon a square, and nothing for this b. Okay, now let's see how to find the mean and the variance by using assumed mean and variance method. Okay, so basically to find the mean and the variance, we have two formulas given. So a is the assumed mean. We will assume something, and that the mean is, for example, 6. And the sum of d is basically the deviation, which is x minus a, x being a set of data, and n is the number of data items. So for example, there are 4 data items, 1 2 3 4, so the n will be 4, and this x bar will give us the mean value. Similarly, in variance, we'll have the summation of d square upon n minus the summation of d upon n whole square. So let's do an example, and then you'll understand how to use this. Okay, so in this case, we're given the question. We have the data 2, 5, and 9. We assume that the mean is 6. Okay, so we have the data 2, 5, 9 written like this. We find the deviation. X is the values, these values, and a is the assumed mean. So deviation is basically x minus a. So a assumed mean, 2 minus 6 will give us minus 4. 5 minus 6 will give us minus 1, 9 minus 6 will give us 3, and this gives us a total of minus 2. So the summation of d is minus 2, so we can take out the mean by using this assumed mean method. So x bar we have to find, a we have 6, summation of d we have minus 2, and n we have 3. So there we go, we have the mean. Okay, so variance has the formula summation d square upon n. So we take out the summation, we take out d square. So we square these values. Minus 4 has a square of 16, 1 has a square of 1, and 3 has a square of 9. So we add all of these. This gives us 26. Summation of d square, which is 26, upon n, 3, minus the summation of d upon n, minus 2 upon 3 whole square, and this gives us 8.22, which is our variance we figured out from assuming mean method. Okay, so this was all from the topic measures of variation. Thank you for watching. Goodbye.